Okay, this is 2015 AP Physics 2 FRQ question number 3. In this question, that we have our narrator. He says that cold air sinking near the North Pole causes high air pressure, and the student is going to say, since cold air is at high air pressure, temperature and pressure must be inversely related. So you disagree or agree? Okay, so I disagree. So basically, the reasoning that I would disagree is because colder air has higher density. That's what causes it to sink. So there's more atoms. Essentially, there's going to be more atoms there. So we can't tell whether P increases because there are more atoms, or because it's colder, right? And we should know that it is because there are more atoms, or is a higher density, meaning there are more atoms in a smaller amount of space, right? I guess if we want to use the equation, we could cover all our bases, right? PV equals nRT. Okay, so I think that as n goes up, right, our P is going to go up. So we have more atoms here. That's going to be increasing our pressure. And remember, it's not the temperature that's doing this. Temperature is creating the higher density or more atoms, and then that's what's ultimately changing the pressure. But anyways, I think we're going to use the other part of the problem to essentially prove this guy wrong. Okay, so here's our next thing. Basically, we want to investigate the relationship, right? And so we have all this stuff, and the key is we're looking for temperature and pressure. We're looking for the relationship between that. Now the cylinder with the movable piston, this is going to be useful if we want to compare changing volume, if we want that to be one of our variables. So we're not going to use this. We are going to use the cylinder. We do want to be able to measure pressure. Basin that's large enough to hold it, so we do want that. We do want 2 different temperatures of water. Okay, and we don't need a meter stick. Let's get a thermometer, and a stopwatch is not needed. Okay, you could use a stopwatch, I guess, if you wanted to compare time, but unnecessary for what we need. Okay, so let's design the experiment. Number 1, let's do the ice water first. Ice water in the basin. Okay. Number 2, put pressure sensor, and can we put the thermometer? Yeah, I guess we can put the thermometer inside the cylinder. Step 3, put cylinder in the ice water, the basin in the ice water. Okay. Let equilibrium be reached. In other words, let some time pass. And then we're going to take temp and pressure readings. Step 5. Okay, now we're just going to try it with the hot water. Right, so empty bucket, basin, place hot water inside, and then we'll essentially repeat step 3 and 4. Put cylinder in hot water and take temperature, pressure readings after equilibrium. Suppose you could also, start with ice water, and then every minute or so, when you put in the hot water, every minute or so take a reading, and you could produce a nice graph that way. The way I'm doing it is essentially just going to give us 2 readings. It's going to give us a hot and a cold, right? Hot and a cold temperature, whatever, and a pressure 1 and a pressure 2. But it should be sufficient to do it. If you really want to be detailed, again, you do some kind of versus time graph. Kind of have your pressure here and just see how the pressure changes over time, right? P cold, P hot, as the temperature rises. So that'd be an interesting one to do also. All right, letter C. They're going to give us some data here. Let's see, where is it? Here we go. They're going to give us some data. And they're asking you which of these titles is going to be useful if we want a nice graph. So when you look at this, the thing you should notice is, again, we just want pressure versus temperature, and what you're going to notice is that you have a bunch of different volumes. So you definitely want to choose something that has the same volume. You'd probably want to choose something that has the most amount. And just at first glance, it looks like the 5 is going to give us the most data. That'll give us 5 points. 1, 2, 3, 1, 2, 3, 2, 3. Yeah, so it looks like 5 is clearly what we want to use. So we would use number 2, 2, 5, 8, 11, and 14. We want a constant volume, and the 5 centimeter cubed has the most data. So that's why we're choosing it. Okay, all right, final question. I guess we got 2 more. So we're going to go ahead and just simply graph this data, and it should be easy enough, I guess. So we have 0. So let's call this temperature. 0, 20, 40, 60, 70. So 10, 20, 30, 40, 50, 60, 70. That'll get it for us. Get it done. 30, 40, 50, 60, 70. And then our pressure, we got 200, 220, 230, 240, 250. So we'll just go 200, 220, 240, and I don't know, 10, 20, 30, Let's just do that. 210, 220, 230. Use a pencil on your FRQs. 250. There we go. Okay, so this is pressure. Don't forget to label your data tables, kilopascal. Okay, so we got temperature of 0. 0 is of 200. 20 is at 220. And 40 is at 230. And 60 is at 240. Is at 240 and 70 is at 250. Ooh. Okay, 70 is at 250. So it looks like it's linear. So what else are they asking us to do? Draw a curve or line. So yeah, that doesn't look, if they would have placed that somewhere like right there, probably would have curved that, but it looks like it's clearly going to be a line here. Let's see if I got a ruler. I don't, but let's just use this. So draw our best fit, equal points above, equal points below if we can. Something like that probably. Okay, what can be concluded from your curve line about the relationship between pressure and temperature? Pressure and temperature are directly proportional. Okay, in other words, P is proportional to temperature. And we know that, by the way, in advance, right? Because we know PV equals nRT. But our experiment kind of shows that. Okay,